everyone. I'm here to talk about optimizing analytics platforms with ClickHouse. Obviously, thank you to the Cloudflare team and ClickHouse for inviting me to come talk today. I'm Gary. I'm one of the co-founders of Explo, and I'm really excited to be here to kind of chat about this. First of all, what is Explo? My team has asked me to ask you all, has anyone heard of us before? Raise your hand, maybe. Okay, cool, a few of you, awesome. So Explo builds customer-facing dashboards and analytics, but let's first talk about that in the context of a customer example. So one of our customers, Lunchbox, they are a company that does enterprise order management. And so if you've bought anything online for Chopped or Paris Baguette, et cetera, on their app or web ordering workflow, you would have used Lunchbox to do so. And so what does that mean? It means that they're actually storing a lot of data and collecting a lot of data around who bought what item, how much order flow is going through per day, and other things like that that you might obviously be able to guess as a company that is the backbone of this kind of ordering workflow. And so what we've done, and this is not the exact dashboard that they use, but an example dashboard that we've created to kind of mimic what it would look like, is that they've created these dashboards in Explo that they embed directly into their own application for their customers that have information like net sales, orders, average order size, et cetera. And so essentially the way that it works is that we allow companies like Lunchbox to come into Explo, really easily build these dashboards, be able to kind of design it and style it however they like, and then embed that in a white labeled fashion into their own application. So our mission, Explo, is the customer-facing analytics platform changing the way companies think about sharing data with their customers, or who I will call in this presentation, end users. Let's define some terms just so that we're all on the same page here. First is data orchestration, which is the thing that we're trying to optimize here, is basically how querying data is performed and how data flows through an architecture to the desired destination. And then analytics platform can be an internal or external platform, but for the purposes of this discussion, obviously we'll use Explo as the example. And so kind of, again, more visuals to show what I was just kind of mentioning. The way that you actually connect and use Explo is one, we connect to your databases or data warehouses. One of the databases that we connect to, obviously, is ClickHouse, and it's the one that we've been seeing a lot of increased popularity around more recently, especially given customers who have a large amount of data and want certain types of pretty expensive analytical workflows. Requires them to actually utilize things that aren't just Postgres databases to get the kind of performance that they're expecting. Second is you actually go into the Explo application and you build these beautiful visualizations. You go into our styling feature, and you actually go and style the dashboard. It's kind of like a UI on top of CSS. There are other bells and whistles here, but we don't need to go into that more deeply right now. And then finally, you actually get the ability to embed this into your application. This could be via a web component, via an iframe, and there are kind of other things that I can kind of expand upon here, but let's kind of dive into some or the data kind of connecting side and the fun stuff there. Here's just some quick examples that I wanted to show you before kind of moving on into kind of the meat of the discussion. So there are a few optimizing constraints that I think are worth kind of discussing and just kind of putting on the table so that everyone is on the same page. The first is that there are a lot of levers that you can pull, but at the end of the day, the levers exist on both sides. It's a two-way street. So Lunchbox, the company, has things that they can do, but also Explo on the analytics side, there are a lot of things that we can do as well. But if we aren't working together to actually help optimize certain workflows, we can only get so far. And so we have to be able to kind of leverage the cooperation and kind of the partnership we have with a lot of our customers and companies. The second is that you can't have it all. There are kind of a tension between data freshness, how cheap your workflows are and queries are, and how quick the actual latency is. And so figure this would be an interesting way to describe there's obviously this push and pull when it comes to data freshness, data latency, cost. If you want things to be extremely fresh, so every time you make a query, it's exactly what's represented in the database, then you can't be using any caching, so the actual query might be slow. If you actually don't mind the data to be a day old, then you can actually do a lot of caching and get benefits there, and the data latency can be really fast, for instance. And then obviously cost comes into play depending on the actual database you're using, data warehouse you're using, how complicated your queries are you materializing your views, things like that. Okay, so now let's talk about steps to optimize analytics platforms. So first, you or the company, and the two-way street, the company needs to be able to choose the right DB that makes sense for their workflows. So first, you got to choose your character. In this case, there are a bunch of databases that obviously Explo connects directly to. At the end of the day, like, we're agnostic. You can choose whatever you want to use, but we have preferences, and we also have suggestions for what might make more sense, depending on, again, data scale, data queries that you're running, kinds of dashboards that you want, latency, freshness, et cetera. But here are some of the examples of databases that we connect to. And obviously, like I mentioned a little bit earlier, we've been seeing a huge surgence in popularity for ClickHouse, given kind of like the nature of queries and kind of analytical workflows that people are trying to perform within Explo. Obviously, the people who actually work at ClickHouse here know this way better than I do, but a few reasons why we push a lot of people towards using ClickHouse is obviously speed and performance, scalability and concurrency with OLAP database structure, indexing, query optimization, handling large query data sets, cost efficiency, et cetera, et cetera. Don't need to go into much detail here, but just kind of wanted to like make sure I kind of call that out, especially given the kind of surgeons that we've been seeing on our side. Now let's get into some more of the meat in terms of like what we as Explo can do and have done to optimize the actual data orchestration when it comes to having that information flow through our architecture. So I actually gave a similar-ish talk in December 2023 when we actually just started to transition some of our architecture to this like new age that I'll be going into. And a lot has changed since then, and we've learned a ton, and so I'm excited to kind of like talk about that. So quick aside that I think is just like a funny kind of anecdote is that, so obviously the old data orchestration is called Data Orchestration V1, and now we're building Data Orchestration V2. The name's pretty boring. So internally, we actually call this FIDO. But like, what does FIDO mean? Why do we call that? And we've actually started to call that externally as well. So I didn't personally know this, but there's this concept called a backronym. And so a backronym is like you create an acronym that you want, and then you find words to fit into that mold. And so our team is very interested, our engineering team is specifically, into like dog-related acronyms. And so FIDO is the Fast Interoperable Data Orchestrator. Clearly, we did not pick FIDO for because this makes the most sense, but it made sense to us, and this is why we're using it. Here's another fun one for you. We have another microservice that I won't go into much more, but it's called Rover, and it stands for the Reliable Orchestration Vehicle for Emailing Reports. Okay, we'll move on. So let's dive in. Data Orchestration V1. How does this work? Let's kind of like hop over here. So this is the Explo application. This is where you go app.explo.co. You go into our application to go build the dashboard. We obviously hit the internet and hit our set of APIs. Our API obviously controls, like has a stateful Postgres database for Explo state, has like dashboard configure information, query coordination information, handles authentication, authorization, et cetera. So we connect directly to our customers' databases and data warehouses. So in the Lunchbox example, we connect to their database that they have. And so our query coordinator is connecting directly to the customer cloud. This is theoretically more or less black box to us. We don't know very much about it. Obviously, we'll communicate with the customer, and so we'll have some information. We'll tell them to make sure that they have, our egress IPs allow listed, or if there's other kind of connection kind of methodologies that we'll need to talk with them about, like SSH tunneling, et cetera. And then when you actually embed the Explo application into, let's say, app.lunchbox.io, what happens is then the Lunchbox app will then go to the internet, talk to the API that we have, and then our query coordinator will then hit the customer cloud to be able to like query the data, send it back through. So there's a few issues with this architecture, although obviously it helped us a lot and helped us get pretty far. but we obviously only could get so big and only handle so much traffic with it. So the first is that query coordination is hosted in US East 1. I realize I'm probably in your way over here, so sorry about that. So what this means is that this actual this is hosted in a cloud instance in US East 1, so our query coordination takes place in Northern Virginia, whereas our customer databases could be anywhere in the world. Let's say AP Southeast 1, which I think is in Singapore. And so what happens is that in order to actually communicate with Singapore, we have to make a couple of hops, maybe through an SSH tunnel, and that connection cost itself is pretty expensive and pretty timely. And so it's expensive from a latency perspective, and then if people have region-specific data requirements like GDPR, we actually won't be able to work with them because sometimes GDPR requirements is that the data can't leave the EU, but in order to actually work with Explo, the data will ephemerally pass through Northern Virginia, and that's not gonna work. The second is that if we have some few customers in the healthcare and in the finance space that actually use Explo in an on-prem fashion, meaning they actually deploy some part of our architecture in their own VPC. In order for that to work, we actually have to host this in a single tenant fashion. It's pretty expensive for us because we're actually hosting an entire new set of Explo auth, our new state, Explo dashboard configs, and that's pretty duplicative, and we don't need to be doing that. And then additionally, our query coordinator is competing for resources with other parts of this box here. And so what that means is that this box manages things like actual dashboard building. So if you log into app.explo.co, you're building a dashboard, you're moving things around, all of those queries will go through here. But also, if you have a dashboard in production that's being loaded 1 million times, let's say, all of those million queries also go through here. And so they're kind of different from a methodology perspective sets of work that's being done, but someone who's hitting production dashboards could actually be using resources from folks who are actually trying to build dashboards in Explo. And so when you're really early on, you don't notice that is going to be an issue until things start to scale a little bit more, and then you realize there's resource contention that's happening, and maybe not the most ideal fashion. And then the last thing I'll call out is that we utilize non-persistent connections here. So that means that the query coordinator communicates with the customer database, and every single time that happens, a new database connection is made to make that query. And so to make this make a little bit more sense, so let's say there's data panels A, B, and C. If I load this dashboard, in order to actually make information load on each of these data panels, A will make an independent connection to the database, B will also, and C will also, and now we have 3 new connections. Once we get the query that we need and the data that we get back, those connections will be closed. And so, again, makes sense on a small scale, but if you can imagine, some of our customers have millions of dashboards that are being queried and loaded, let's say, in a given hour, and that's 1 million times the number of data panels that exist needs to have open connections to that database, which doesn't make sense. So enter Fido, again, the fast interoperable data orchestrator, and how we thought about optimizing some of those constraints and issues that we talked about. So again, I'll walk through and build out how the architecture is constructed. So obviously, app.explo.co, we just talked about that, flows through and hits the API. The API, as you can see now, is much more slimmed. It just handles auth-n, auth-z, as well as has Explo state dashboard config, which basically means where things are on the dashboard and other information similar to that kind of metadata. We have a separate microservice now, and so this is what we call Fido, essentially. And so right now it's called region.data.explo.co, and so this is a region-specific VPC where we can actually have our own microservice that manages querying specifically. And so now, in order to talk to our customers' databases, all that happens is this box here is talking to that database directly. So this box does not need to care anything about it anymore. We've also added a few other tunneling options. So obviously, from Fido to the customer database, you can go via the public internet, SSH tunneling, transit gateways, or private links if you're using AWS, IPsec VPNs, direct connect, et cetera. And then obviously, here's what happened. Here's you add this piece, which is the actual customer embed. and that flows through kind of in the same kind of pattern-matched fashion as I explained previously. The interesting and neat thing here is that because this is a microservice now, you can actually deploy multiple instances of this FIDO microservice. So it could be separately hosted in a single tenant fashion or in a multi-tenant fashion, but across different regions. And I'll go into that a little bit more later. So some of like the obvious benefits of this architecture that I'll kind of like lay out. So the query service is hosted in any region, which means that it can be co-located in AP Southeast 1 with where the customer database is. So that actually helps a lot, obviously, when it comes to kind of the round trip times of data. And then also we have and can host this in like the EU as well to handle GDPR constraints. We can independently deploy one of these as well on a per customer basis within their own VPC if there are any type of like really strict data residency requirements that they might have. We have dedicated query resources now, as you can see here. And so like there's no resource contention that happens between the Explo app itself and our actual query logic. And then the last piece is like we have persistent connections. And so FIDO will maintain a pool of persistent connections via connection pooling to the customer databases. And so there's not that overhead of making a new connection that we used to have every single time. And so if you're wondering what connection pool means, this is kind of like what it means. So same ABC structure. We now have this connection pool. Let's arbitrarily say there are 2 connections that exist. What happens is A, B, and C in a non-deterministic fashion will wait for open connections that are available, and then these connections that already are connected to the database will run the query for them and then pass the information back. And so you can see there is some kind of tuning that has to happen between us and the customer to kind of allow for even more optimal query patterns to take place. For instance, the number of connections that we want in the connection pool is one of them. We have like a default, I don't remember exactly what the number is. It might be 5 or 6 across like 6 nodes that we have. Don't quote me on that, but that's like an example of a lever that we pull with our customers. And so here's an example of kind of like the general architecture that I just described. This is what it looks like. But in reality, it actually looks like this today. And so we have one FIDO instance that's in US East 1, one in AP Southeast 1, one in EU Central 1, actually one in US Gov East 1, because we actually have a few customers who need GovCloud. And then we have N number of customer ones as well that we have deployed specifically on a customer-specific basis. Obviously, this is much more expensive for our team to maintain and kind of like help them out with. So we only actually let folks have their own instance on like the enterprise plan. And so depending on where like the constraints of the database, like we will have a different FIDO that's connected to them. And so when you actually load the dashboard and the embed, so to understand where the dashboard config and how the dashboard's laid out, it'll go to the internet, hit the API, get information about, all right, we have a KPI over here, a bar chart over here, a map over here, send that information back, and so then now you have the dashboard skeleton, but there's no data, and then independently of that, what happens is then it'll fire a new request to the right FIDO instance that's connected to the data source, and then it'll then make that query, let's say to AP Southeast 1, it'll then go to the customer database, get the right query, have the query run, get the data, and then that'll send back and flow back, and then all those what were originally like placeholder blocks for all the charts will then load with the corresponding data. Cool, so then you can kind of see just a visual for like kind of like the regions that we're in, and obviously it's pretty easy for us to add more. And so that's kind of like what the query orchestrator that we did and kind of like the advancements that we kind of improved there. It's been really awesome to kind of see that unfold, and actually the way that we've built it makes it very kind of modular and extendable, and so that's kind of like what we're really proud of, and allows us to be very nimble depending on our customers' data requirements that they might have. So the next piece is something that we can also do as well than that we have done, which is implement caching. And so when it comes to caching results, I think it's like a pretty trivial workflow. I'll kind of like walk through it here. the dashboard's blank. It'll first check the cache if the actual data that it needs is actually there. If there's a cache hit, it'll just pull the data from the cache, and the dashboard will load. If it's a miss, the dashboard will then ask the database for information. The database will send information back, and then also warm the cache. It's not a really complicated concept, obviously, and we internally use Redis and Apache Ignite. The interesting thing here to call out is that the cache key that we use is the query itself, and then there's some nuances there a little bit later that we can talk about. Data is held in memory and never actually written to disk, which is pretty important because we don't actually hold and store any of the data from our customer side, which is like a security kind of guarantee that we have. And so it's default turned off, but people can optionally turn it on if they think it makes sense for their workflow, for their data requirements, security requirements, et cetera. And then obviously each FIDO instance handles its own caching because you can't be caching in US East 1 if it's like a European EU FIDO instance that we have. The next thing that we are actually in the works of building is called cache warming. Also not too complicated of a concept, but I think it's particularly interesting because basically when you want cache warming, you want faster queries, but then the freshness of the data only matters within a range. So let's think about it like this. So we have a customer, let's say Lunchbox again, who thinks that like their queries, as long as they're within an hour of freshness, is good enough. But their queries take a really long time to run. And so what they actually might want to do, given their like engineering constraints, resourcing constraints, they don't have enough time to optimize queries and stand up new workflows to make that more performant. What they can do is do something called cache warming, which is like on the every 59th minute, you go for all N customers that you care about, for all Y data dashboards that you have, you load the right information that you need, store it in the cache in kind of like a headless browser type way, and then all of those queries are kind of pre-warmed for your customers. So then like, let's say customer 5 loads the dashboard, they just go straight to the cache, it's always gonna be a hit, and then they get the information back. And then at the 59th minute, when the information is about to get purged from the cache again, you rewarm the cache. Obviously, there's a lot of nuances. How long does the query actually take to run? So you might need to do this in the 55th minute, 54th minute, et cetera. A lot of kind of like empirical data will be helpful here. So the pros is that it's like fast with fresh enough data. The cons is that it's pretty expensive because maybe you're loading for N customers, but only like 5 of those customers actually load the dashboard, and then like N-5 loads were basically unused and thrown away. And so that's like something to consider. It's hard to warm everything. So remember I mentioned that like our cache keys are the queries themselves. And so if anyone has a filter that they want to change on the dashboard, or if they want to make any adjustments or kind of like drill in, all of that needs to either be pre-warmed or it can be a pretty clunky experience because the dashboard loaded really quickly, but immediately after applying a filter, it takes a long time to actually get the results. And so then another thing is like we have what's called like relative time filters. Relative time filters are like, I want to see information from the last 30 minutes, right? And so the last 30 minutes on a per second basis changes every second. And so you actually can't really warm things in an intelligent way there because if you warm it, it'll immediately be not relevant a minute after because that cache key will never be hit again because that time has passed. And so there's a really interesting kind of technical challenge around relative time filters that is going to be really baked into kind of like the user experience and kind of like constraints that we have to have like handshakes with the customer around. Cool. But TLDR, ways that you can kind of optimize queries and kind of like analytical platforms like Explo. 1, choose the right database for you. What might work for you might not work for someone else, so keep that in mind. 2, use a platform that actually has optimized their data orchestration and has thought about ways that they can improve the flow of data through their ecosystem and architecture. And then 3, think about how to use caching correctly. Like what might, again, work for you and your system might not work for other people's. But I think that's pretty important as long as you have an understanding of what your constraints around security, freshness, cost, et cetera are. Awesome. Any questions? Yeah, let's start here.
Ask you who writes the query?
Yes. So our customer is the one writing the queries.
Yeah.
And so what happens is that they will write like base data sets.
Yeah.
And then within Explo, when you actually construct the dashboard, we'll essentially take those base data sets and do some query generation around it based on if you're using a bar chart, a line chart, et cetera, and if you need some aggregations. Like we do some of that query gen for you.
Was there any problem like for the query performance? Because query performance depends which database they use. So.
Yeah, it's actually a good question because we were just helping a customer today, and depending on the database they use and even like the version that they're using, the like execution plan can be quite different from database to database. And so even though like we are generating pretty simple things that we're adding to the existing data set itself, if you're using Postgres 14 versus Postgres 13, like the query planner might actually do something a little differently. And so like depending on the circumstance, like we're trying to do things to like make it so that it's more deterministic across versions, but there's only so much that we can do. So we also try to push them to choose the right database, but also upgrade their databases so that it's a better query planner that exists.
Thank you.
Yeah.
Yeah, thanks for the whole walkthrough. It was really interesting. We at Chartmetric have done some of this sort of custom dashboarding, customer-driven analytics before. And a challenge I'm curious about how you solved was, where does the query live and where do the parameters live? Because when you have something like a relative time filter or a multi-select on the browser, those parameters have to go somewhere. The browser has to know what the options are, and maybe those options change over time.
Yeah.
And so that's a really ambiguous challenge, and I'm curious about how you guys sort of approach it.
It's a really interesting question. In our old V1, they all lived in the same place, which was kind of like the issue. And I can kind of like go to the V2 architecture to kind of point out. So the queries themselves, that information lives in Fido. And then like we have what's called like our customer information. So like we have these concepts called the customer objects within Explo. Customer objects essentially are like anonymized information about who you want to show the embedded dashboard to. There's information at the metadata level there that could be injected into a query depending on how you use properties. And like that lives in this box or in the actual like Explo state that happens within the API. And then there are also like a set of variables that you can pass in that are parameters that actually are passed in at embed. And so then like people can pass in parameters here that we actually don't really know anything about, and they're just actually ephemerally passed through and from the browser, correct. And so you have to do obviously the right sanitization and all of that
right, yeah.
that comes
that
with that. It's like a pretty
complicated.
Yeah, there's like pretty complicated things that we've had to think through, and you can imagine pretty weird and not very fun situations that we've been in before, but it's all kind of like a learning experience there, and once you kind of get past it the first time, you kind of don't have to deal with it again. But yeah, parameterization happens in a bunch of different places. States, like we hold state in a few different places as well. There's constant debates internally in terms of like, should we have the state be held somewhere else and all of that, as I'm sure you can imagine with your experience.
Oh, yeah. That's why I asked the question.
Yeah,
so,
it's a hard one for sure.
Yeah, thank you.
Yeah.
I have a question regarding your cache and cache forming strategy. So
Sure.
it sounds like based on the relative time, you support minute or hourly granularity. And I was wondering, when you do the cache forming or decide how to store those, I'm guessing the queries themselves have date ranges or timestamps boundary on them. And what was the optimization process like that for that in order to maximize the cache hit rates?
Yeah, so depending on like the relative time filter, if I'm understanding your question correctly, and like the level of precision that they need, so like by the hour, by the day, by the week, like that's also pretty important too. So like if you only care about the last month, then there's like some rounding that you can do that actually pre-warming is pretty cheap. If you care about on the hourly basis, then it gets obviously maybe more expensive, like minute, that's like crazy expensive, obviously. So there's like a number of things that you can do. I think at the end of the day, it's like based on your appetite towards cost, performance, and kind of like that Venn diagram that I was describing. It's really hard to like generally provide like here's like ways to do it. What we figured out is like there oftentimes when it gets that nuanced, you have to actually kind of understand the actual customer's constraints and like what their business reasons for wanting cache warming is. My immediate default is that if you don't need a cache warm, you shouldn't. Like, you should find ways to materialize the data. You should actually just like query it in like a more kind of like first-class way. If you from a resourcing perspective, engineering perspective, whatever, can't do those things that we would recommend first to actually help make that experience more reliable, then like, sure, like let's talk about cache warming and how that might be, a backstop for you.
So what I'm hearing is that you're allowing the customers to define what
Yeah,
they
so
want
we
the
work
windows
with
to be.
we work with them on that, yeah.
So you guys have a lot of copies of this Fido thing that you guys are deploying, right? And so you have like single tenant instances for some of your enterprise customers. How many of those are there, and what kind of challenges have you guys run into, like managing all those? Like, are they all in the same version all the time? Do you have some sort of like staged rollout strategy? What is that?
Yeah, they are all on the same version right now, and I hope that stays the same. The reason I say that, and there's a little bit of an engineering decision that our team made that I think was like very smart, is that we actually don't deploy in the like customer-owned VPC. Like, we will create like a shared VPC, or like we'll create a sub-account where like our team is actually an owner of it too, and so that we can actually go in, look at logs, push changes, et cetera. And so right now, our deployment process will deploy to all of these, obviously the ones that we own, and then all of the customer ones too, because technically we are an owner of them. And so in a sales capacity, we call it like dedicated hosting, because like it's like a dedicated like VPC for them. It's a VPC that they own in conjunction with us too.
Do they actually have access to the VPC at all? Or
They
just
do,
managing?
yeah. They can have access if they want. Not everyone actually wants it, to be honest, but they can.
Interesting. Okay.
Yeah.